Hi everyone, welcome to my YouTube channel. This is homework 6, problem 1. In this problem, we have the joint density function of x and y. This part is the joint density function, and the first question is to compute a, and so first let's do the integral of x and y from minus infinity to infinity, and we have the absolute value of x and y both less than 1. So we can do the integral from -1 to 1, and let this integral result is 1. So we have the constant a, the capital A is 4, and in the later question we need to compute a bunch of expected value. So the first one we do is the mean of x times y, and we do the integral of xy times the density function of fx in y, and this part is a odd function, so this should be 0, and we do the later one is the final result is 1/9, and then we do the mean of x, and the result is and we know this is it should be the all this equation should be all, this function should be all functions, so the final result is 0, and so it is the same way with the mean of y. So both of these two value is 0, and we have the mean of x and y is not equal to the mean of x times the mean of y. So they are not, the variable x and the variable y are not uncorrelated, so they are not independent. And in the fourth problem, there's two function. The first one is z equals to x squared and w equals to y squared, and we already know that the absolute value of x and y is less than 1, so we know the z must more than or equal to 0 and less than or equal to 1, and it is the same with w. So we do the so we have the capital G, which means we do the derivative of a two-dimensional matrix, and then we do the determinant, and we have the final result is 4xy. And according to the definition of z and w, we know that there's 4 roots between this interval. So we have x equals to square root z and minus square root z, and so is y, and so we have the joint density function of z and w. So this is we get the common term, and we have the final result is 1/4 times square root z times w, and this is a z and w's interval. And we might notice that this term is exactly the same margin density, the margin function of z and w, and it is easy to verify it when you do the integral from 0 to 1 with respect to z and w, according, of course. And so we know that this x, z and w are independent, which means x squared and y squared are independent. So that's the first question.